Thanks. So I'm very happy to present our paper on describing deferred acceptance and strategy proofness. And this is joint work with an amazing research team, Yannai, Ori, Guy, and I'm Clayton. Okay, so in this paper, we run a lab experiment on the classic deferred acceptance stable matching mechanism and the celebrated strategy proofness property that DA satisfies. So DA is this classic stable matching participant proposing type of mechanism you've probably seen before. Strategy proofness is this classic property that says, in theory, there's no reason for you to strategize. You can just submit your true ranking of the outcomes and you'll be good. However, in practice, we see a pretty large fraction of deviations from this theoretical dominant strategy. This has motivated a lot of literature so far, and in this paper, we ask, how well do participants actually understand DA and understand strategy proofness? And can changing descriptions of these two things improve their understanding? So given these questions, we kind of separate out things into these four boxes: DA, SP, and then from the description of SP, we separate actual understanding of SP. And finally, how you actually behave in DA rounds. So what we're actually going to do in the experiment is describe either DA or SP in either classical or novel menu versions inspired by our previous theory paper. So in particular, there'll be 5 treatments, 2 for DA, 2 for SP, and a baseline close to zero information treatment. And so when we take all 4 of these boxes kind of seriously, this leads to some kind of novel design features, such as what's playing here is our ranking UI, our proposal algorithm UI that we developed to really be sure that participants understand DA and to measure their understanding. Second novel feature is a strategy proofness understanding test, asking participants to apply the definition of strategy proofness. If you ranked like this and got this in some counterfactual, could you have gotten that? Questions of that nature. And finally, as is standard, we track how you actually play in real incentivized rounds of DA. A preview of our results. First, we find that indeed many participants can understand DA. However, such understanding does not imply an understanding of strategy proofness. However, a novel menu description of strategy proofness can indeed convey this property significantly better than other treatments. And fourth, we find that while effects on behavior, on your actual rankings, these are small on average, participants with very high levels of strategy proofness understanding indeed play the classically dominant strategy at very high rates, suggesting they do act on this understanding. Before proceeding, I want to sketch out a little what this paper is not about, just for clarity. So it's not about non-standard preferences such as loss aversion. Instead, we focus on misunderstandings of DA or of SP. And it's not about changing the interactive mechanism. We'll never do something like, hello, your options are 1, 4, and 5. Pick your favorite from these guys. Instead, we consider static mechanisms where you submit your ranking to the mechanism and we change only their description. It's also not about trust and it's not about advice. It's not about things like we recommend you to rank the outcomes from your favorite to least favorite. This is a very interesting thing to do, but we focus on the strategy proofness property, this kind of concrete fact about how your own ranking can influence your match. Additional related work, I've already mentioned our theory paper where we introduce menu descriptions. I'll tell you what that is later. There's another working paper which also conducts an experiment for matching mechanisms on menu descriptions. They look at the top trading cycles mechanism, but they don't include a lot of our novel design features. They don't train the participants, they don't have measures of SP understanding, and they don't have baseline treatments. Still, we build on a lot of works from the previous slide in the way we train participants, where we kind of formalize it into this interface and really take it seriously as an outcome variable. We build on lots of other works, but in the interest of time, I'll dive into the experiment design. So the first thing we do is just tell participants the basics, the basic environment. We describe to them DA or SP in 5 different treatments, and we train them on these descriptions. Then they play 10 incentivized rounds of DA for real money. And then we measure strategy-proofness understanding using novel tests. So going through each of these, our DA setting, so there's 4 participants, 4 prizes, each prize worth a custom amount of money to the participants, and you play against 3 computerized participants. The prizes have priorities over the participants. So if you are 3rd priority at A, this is kind of the prizes preference for you in the DA algorithm. Each participant sees this, and then they rank the 4 prizes however they want. We run DA, and you get your outcome. You earn some money based on it. This is the very basic setting description. Then our 5 treatments differ in the actual description, what we're telling them about how the process actually works. They differ in that description, and they differ in the training that we use to both improve their understanding and measure their understanding. So what's the traditional description of DA? This is probably what you're familiar with. This is the classic participant proposing DA algorithm. We look at your rankings. Each participant proposes to their highest ranked prize. We look on each prize's priority list in order to break the ties. In this, each prize keeps their highest priority thing. We continue until all participants receive a prize. This classic algorithm satisfies strategy-proofness. It is a fact that it's strategy-proof, but should this be clear? Should this be clear from the algorithm? I don't really think it's jumping out at you still after a few years working on this kind of topic. I don't think it's super clear. Yeah.
Do you try to convey to the participants that the prize priorities are fixed and not dependent on?
Yes. So both the prize priorities and other participants' rankings, we convey that they're determined independently of your ranking. So motivated by strategy-proofness, we proposed in our theory paper a novel menu description of strategy-proofness. So this goes as follows. A menu of obtainable prizes you may receive is determined using only other participants' rankings. The contribution in the theory paper is to characterize this menu and find a real algorithm that implements it, which I would love to tell you about. It's one of my favorite theorems I've proved, but for time, I'll skip it today. It's some modified form of a proposal algorithm. And then out of this menu, you receive always your highest ranked prize. And this is designed specially so that strategy-proofness is easy to see, exactly in the sense that it follows from a 1-sentence proof. Namely, you can't influence your menu just by the structure of it. It doesn't look at your own ranking. And straightforwardly ranking things from favorite to least favorite gets you your favorite obtainable thing on the menu. And this is possible for any mechanism that's strategy-proof. It just differs in what is the actual algorithm here that you're gonna have. So to illustrate it graphically, in the traditional outcome, we just combine the inputs to your allocation. In menu, others rankings and these fixed prize priorities get your obtainable prizes, your menu, and you're always receiving your highest ranked thing from the menu. Yeah.
In a traditional DA, do you tell them it's strategy proof?
No. So this is the starting point of the new experimental paper, but it also leads to a major design challenge. These somewhat involved combinatorial algorithms really have to be understood by the participants, or the treatment effect might be unrelated to what we actually want to measure, the real content. And this leads to our strong emphasis on teaching and training our participants. We develop this GUI to allow them to actually calculate their DA outcomes. We do careful instruction, hand-holding walkthroughs of the proposal process, and then they have to calculate things for themselves. So here is the actual treatment description. We won't go through it today. You can see indeed menu is longer than traditional, but it's still something you can convey to people. They kind of click through bubble by bubble. And then they receive both coaching and measurement of their understanding via this GUI. On the left, you see traditional. This is actually the participants getting tentatively matched to the different prizes, and you continue proposing in that way. In menu, first you do something like this, then you actually calculate what is your menu from this proposal algorithm calculation, and you write down what I actually receive at the end of the day, where traditional, this is just kind of repeating information from the UI. All right, so here are the first two treatments. Here's the idea behind menu descriptions. Given these, if you think for a little while, a pretty natural idea comes out of this. So just simply take this menu idea with this detailed combinatorial algorithm and only tell you what's important for strategy proofness. Omit the details of what the menu actually is, but tell participants this two-step thing. We'll determine your menu using only others rankings, and you'll get your highest ranked from the menu. And this is our third treatment, menu SP property. But observe that where DA mechanics, it really told people exactly how to kind of mechanically calculate their actual matchings. Now for SP property, we've told participants nothing whatsoever other than that the mechanism is strategy proof. If you think for a little while, every mechanism is going to have some outline like this. So we've only told participants that it's strategy proof when we do this third treatment. And this is why we include a fourth treatment as a level sort of fair baseline. Another one where we tell participants nothing more or less than this is a strategy proof mechanism. This is with a sort of standard textbook description. We just, in non-mathematical language, write that the prize you receive upon submitting list L is at least as high according to L as any other prize you would receive under a list L prime. Finally, we give a close to zero information null treatment that just sort of repeats the basics. A zero information benchmark. So here are the actual most important parts of the treatment text for SP property. For menu, it just tells you, note that your ranking does not influence the obtainable prizes, but it does help you get your obtainable prize that you ranked highest. This is the main thing about the menu SP description. There's also training for the property treatments. For the null treatment, you just repeat in this description phase the basics that I showed you at the beginning of the design. So I've covered a lot already. This is a complicated experiment, but I've only covered our first outcome variable training score. So across these 5 treatments, we are measuring how you actually understand the description itself that we give you. There's 2 more outcome measures. Luckily, these parts are a bit simpler. There's your ranking behavior in 10 real rounds of DA and understanding of strategy proofness via novel tests that are the same across all of the treatments. So ranking behavior, you see this information, your values, your priorities, you submit your ranking and you receive a prize, you earn some money. This is the ranking behavior. We track whether you rank straightforwardly in this classically dominant strategy. And then there's an 18-question test on strategy proofness. So this contains 13 questions on the abstract sort of logical definition of strategy proofness in hypothetical scenarios. These are things like, if you do this ranking and get C, would this ranking have possibly gotten you A? In this case, the answer should be no. There's also 5 questions on the practical implications of strategy proofness towards how the participant can maximize their earnings. For example, should I look at my priority table? Should I look only at my values when I choose my own rank? In this case, yes, the participant should only look at their own ranking if they want to just maximize their earnings. We conduct the experiment at Cornell and online at Prolific. This gets us pretty good heterogeneity between things. Findings replicate across this and also across measures of cognitive score, so I'll pool things for the top. Great. Now I can get into results. Recall that there were 4 in the intro. I can sketch out these 4 now. Result 1 is that we can teach DA to normal non-expert people in 20-30 minutes. In particular, for the traditional description, we get pretty good training scores throughout. In the hardest, least handheld problem, this is where they work a complete instance by themselves. Still 3/4 of participants just get it perfectly on the first attempt. You can see this longer, more involved menu algorithm is indeed much lower in training score, but it's still showing that this is a thing you can teach to people. This is possible, and if people are paying enough attention, they indeed get it. Result 2 says that understanding strategy proofness is understanding DA is very different than understanding strategy proofness. So looking at the DA mechanics treatments, traditional and menu, both are very close in SP understanding score, that's on the y-axis now, to the null benchmark treatment, where we've told you almost nothing. We've just told you some matching algorithm will be calculated using your ranking. You can also look on the 2D histogram. So now x-axis is training score, just understanding of the description itself. Y-axis is strategy proofness test. What you really want to take away from this is just that even the best description understanders typically are not good strategy proofness understanders. Most don't move into this higher region of performance on the strategy proofness test. And this is true even in the menu version where we made the proof of strategy proofness just so much simpler. When we first found this, it really broke my theorist's heart, but that's how it goes. Result 3 says that we can, to some extent, teach strategy proofness. So looking at our menu strategy proofness treatment, this performs well above the other treatments in this strategy proofness understanding test. The textbook SP also does pretty well, kind of interpolating between these two, but menu SP is the best performer by far. And if you look at the just raw histogram, so this is the overall SPU test on the x-axis here, menu SP is in orange. What you see is that we see many nearly perfect scores in menu SP, and you don't really see this in any other. We also find an interesting degree of bimodality here, particularly in the 5 questions on how you can maximize your earnings. So a lot of people are kind of at this perfect misunderstanding. Actually, more than half of people think you need to strategize on all these inputs. But the second mode is at perfect understanding with a consistent understanding of strategy proofness, suggesting a degree to which you either completely get it or completely don't. The final result is we see small overall effects on ranking behavior. The means move a little bit across treatments. So now we have x-axis being the fraction of rounds in which you played the classically dominant strategy. But the distributions, the histogram doesn't look much different whatsoever across the different treatments. Despite this, we see a strong and global relation between strategy proofness understanding and behavior. So this is a big figure, but what we have on the x-axis is the strategy proofness understanding test. On Y, we bin by the strategy proofness understanding score and track participants' mean ranking behavior, fraction of straightforward play. So what you take away from this is that the best strategy proofness understanders consistently across treatments are indeed very likely to play straightforwardly, kind of act on this knowledge of strategy proofness that they have. You can also see this without the binning if you look at the histograms. So now on the 2D histograms, the x-axis is now strategy proofness score, y-axis is straightforward behavior. And people in the higher regions of strategy proofness indeed typically move up in straightforward behavior. In particular, for our best performing treatment, menu SP, this leads to a strong kind of 2D bimodality, a strong second mode at the higher regions of both SP understanding and straightforward play. Okay, so to wrap up, we find that understanding the description is very different than understanding strategy proofness is very different from behavior. And so you should look at these relationships and measure them separately. It also, our results lead to a very simple policy recommendation, which is to use menu SP property. Tell participants, you match to your highest ranked option from a menu that your own ranking can't influence. And while menu DA mechanics was crucial to us to reach towards this suggestion, it may still be too complicated to explain strategy proofness. Possible future directions are to examine interactions with advice, telling people concretely how they should be ranking, or explaining other things, non-matching mechanisms or properties other than strategy proofness.